Hello, everyone. Today we are going to start the tutorial for OKTex. OKTex is a footwear software plugin from Ryan, which helps you to develop soles, insoles, left, and so on. The first thing we are going to show you quickly is about the interface that we have on the software, on the OKTex software. You can see on the other tabs, you have the standard tabs with the usual tools from Rhino. On the second tab, you have the shoelace tab with most of the tools that we use for shoelace. And then you have the tab EVAs, and so on. We also have an upper toolbar where you can see OKN footwear there. And then you have the modules that we have on the software. Last, insole, sole, EVA, reverse engineering, transformation, utilities, and finally, a help section where you can see that we have it's kind of explorer support for you to help you while you're using the software or just if you want to use it to learn a little bit before starting to use it. So you go on help, for example, wax, that's what we are going to see next. Then you can see OKTex logo, and if you scroll down, you have all the index from what you can see on that tutorial. For example, the first tool that you might use while creating a web surface level. And then you can also see that you have a play sign. If you play it, it's going to show you a video showing you how to apply the tool that you want to learn. So the first thing that we are going to do, and on a usual workflow for creating what I'm going to need on your shoe and insole, is to create the last surface. So we're going to go how exercises, where you can find some exercises to train, but you can also open a last, in this case, class number 35, which is the one that we are going to use to show how to create a last surface. But you please import the STL. And you can see that it's going to open the last, and the last doesn't have a good orientation. It's just basically floating on your screen. And the first step that we are going to do is to give an orientation to this last. So we go on the shoelace tab, and a good tip is that most of the tools, they are in a kind of order that you're going to use. So you go on the first tool that appears, level, and we are going to level the last. Please do select the map. After enter, you have to give 3 points in kind of a triangle over the top corner of the last. So first, second, and third. And the last is going to have a basic orientation. The second step, you can also delete the points. That's what we're going to do. You can keep them there or just delete if you want. The second step is to align the last and to create the mid-length axis. So select the shoe last, manage again, and the software is going to generate the section, the mid-last section. Okay, so the software tries to figure it out where is the toe edge and the heel edge points, but sometimes it's kind of hard. So we can position, we should position it better. So first press toe, for example, if you want to reposition the toe point, and just press where the toe point is. And now you're going to do the same with the heel edge point. So press heel and please do position the new edge point. You can see the software is already showing you the bottom length, in this case 240.7. And if it seems okay, you just press run. So the next step, you can see that you can see a cross section from the last, and you can see that the medial and the lateral side are not really well balanced, level. So the next thing is press balance, and you can see that the software is going to balance both sides of the leg. Now they are okay, and then you press enter to leave. You can see that you can use on the right toolbar, so the last views, so to say. So you can position the last by the back part, the toe part, bottom, top view, and so on. Okay, you can also use Rhino views, but in this case, you can use also the usual footwear over last views. The next thing that we're going to see is that if we see the section, the last mid section that it was created, and you want to realign it, you can go on the third option and press on Align. So this is going to give you the possibility of aligning the mid section a little bit better. In this case, we are going to press degree and define 1, which is 1 degree, and then you can press on right, on left, and you can see that the last is going to turn and align a little bit better if you want so. And if you decide it's okay, you just press run, and so the back profile is better aligned. The next step is to define the feather edge profile, the feather edge line. So we go insole, and on the foot, just press insole, and then insole auto detect. So the software is going to give you a basic feather line. Is do select the mesh and enter. You can see that the software defines the feather edge, but in some points it's kind of tricky for the software to really define where the edge, especially when you have round edges last. Some last just doesn't have any edge in the bottom. We're going to see how to project 2D profile later on the next video, but right now let's just define the feather edge manually. You go on insole edit points. You select the line that the software created, and then you see the points, and you can move those points around just to better position them over the edges of the line. So if you reposition manually on the feather line, so if you want to add or remove any points in order to give a better shape to your feather edge, we can do it using the Rhino command that you can see there, insert none. So You just select a curve that you want to insert in the knot. You insert it, or you can also remove it, but doing the same way. Okay, so we add up some parts. You can at the same toolbar. You can remove, select remove. So you can also remove one part that you don't need anymore. And after doing that, then you go back on the OKN tool, insert, edit points, and you can then edit those points. The only point you can't move is the U edge, this point, and the toe edge point, the ones that you manually created in some steps before. So the insole was created. Maybe just move a little bit that point. It's good to just turn the glass, see differently on different views, so you kind of sure on from the center line was created. And the next step, let's rebuild this center line using the Rhino command, rebuild curve. You select the curve, and you're going to add about 101 points, depending on the lens that you have. So why are we at points? It's also important to keep degree 3 as we are keeping there. You can see then the deviation basically none. You do okay, and you're going to add 100 points to that curve. Why are we adding points at this point of the surface pressure? Because those points are going to basically they're going to be the base for the curves. These are curves that are going to be created. Okay, so the next step is to actually create the surface. So you go on that icon, and then you go on automatic surface creation. Select the show last, which is still on the edge. Then we're going to see a red line. You just position it just a little bit down beneath the glass top cone, and you press enter. And then you're going to see, so there's basically two patterns of creating a surface of a glass. We usually use pattern 2, and we are only going to use pattern 1, which is a G pattern, sure. If you have any troubles using pattern 2, but 99% of the cases you are ready to use pattern 2. Also, based on our experience, we use those numbers 280 and 180 and 351 for creating the user curves that is going to be the base for the surface. But you can just play with it, you can try it, but just start with it. That's based on our experience, that works the best, and then you press run. So we can see the software is already creating the bottom surface, then the upper surface from the glass. And you can see that it created the matches, the user curves, and the matches. You just turn the glass around, check if there's nothing strange. If not, just press yes, and it's going to create the last surface. You can see that now it says matching last surface. What is the matching last surface? It basically creates a base surface, and as for doing a base surface, we have a tool called, we are going to see them later also, match surface. that is basically taking that base surface and it's going to balls to attach basically point per point from the surface to the mesh. So it's going to really copy the mesh really well. You are going to at the same time you just please convert do yes and it. So you can see that it's going to really copy the surface, really copying the mesh really well. It's still going to be a smooth surface, but still copying most of it. So let's zoom in the toe. You can see that there's a slight difference. Let's maybe measure it just to have an idea of that difference. So we are going to see that this difference is about 0.1 millimeters. Usually that's enough, but we are going to show you that we can, if in some cases you have really edgy shaped LEDs, or you have some special days in the LEDs that you want to better define, you can then add either curves. You just go on the fifth menu, add left isogroups. So you can see there's two sections, one and two lines, right? One in the heel, another one in the toe area. So in this case, we are not considering the toe. We are just adding isocurves in a defined area in the toe. So you just press on toe and then adjust. And you can just slide this section to define from this section towards the toe the area that you want to add in. So, and then you can see that it also gives you the distance from the toe to the back, so 20, which is the area from the toe that you are adding. In this case, we are going to zero the heel area because we are not adding any isocurves in the heel, and we are selecting one in the vertical axis and one in the horizontal axis. So in between each two isocurves, you are going to add another one. If you press 2, it's going to add 2. Or okay, let's put 2 and 1, and let's run. You can see that we added isocurves, so we have a more dense net in the toe area. It could be anywhere in the last. And if you want, you can undo it. Let's just undo it to show, and let's add. You can see the difference. And let's now add just one. Let's say we thought if it was too much, and let's do 1 and 2 instead of 2 and 1. You can also, usually in the last, you have those vulgar measuring points. If you want to define those points really well, you can also select the points. Doing by that, you press select, and then you just select the 3 points, usually 3, that you want to better define. So it's also create a more dense net over those points. And then you press exit after selecting the third point. So you can see that you can see those points there, and just run. So we define the points, we define the area in the toe that we want to add is a curve, and now you can see that added some extra isocurves over the points, or the area that the points are. You can see there, and also in the toe as we define. So we will have really well-defined points for measuring the last, or taking those as a reference, and also in the toe. and then we can add it. So since we have more easier curves, we can better define that tool right now. So for doing that, we are going to use another tool, which is match. And we are going to use the first one, surface. So match better a surface to a mesh. Please do select the mesh. Please do select the surface and enter. And now we are going to see that it's asking you about maximum distance. Just keep 15. Just press enter. Keep this configuration, enter again. And let's just wait a little bit. So basically what the software is going to do is, again, to match the surface to the mesh. But since we had some more easier curves in the top area and in the points area, it's just going to copy a little bit better. As we said, you can apply anywhere you have some more easier curves using that tool, and then you can copy it better if you need it. Now, let's see the tool, how it is. You can see that it's better copied. There's basically no difference. Let's just measure that since we measured it before, just to compare. And we can see that the difference is basically known right now. It was 0.15 and it's now 0.02, so none. Okay, so the surface is copying the last perfectly. And let's go to the next step. Let's delete the mesh if you want. If you want, you can also create a new layer, add that mesh to that layer so we kind of have a history from what you created and over what you created. You can either delete so you have a lighter white or just keep the mesh in a layer. And let's turn it off. So when we did the match surface to mesh, okay, the surface copied the mesh really well, but sometimes we lose a little bit the match, the final matching between the surface and the feather line. And what we are going to do is we are going to correct that right now. Okay? So we are going to match the surface to the feather line, but now we are going to use the match surface from Rhino, not from our toolbar. So you go on that command and match surface again from Rhino. The name is the same, the tool is different. So you select the surface that you want to match again. You select the line and you just have to keep that configuration. So position, you have to cross match edges by closest point. At this point, if you do not cross that, it's going to mess it up, as you see, and then you do OK. So you can see that the surface and the feather edge are matching right now. And they are not at that point. So since the bottom line is broken in 4 segments, you have to do it 4 times, 1 for each segment. You just repeat the same command, keep the same configuration here. Now in the back part, and now in the side part. So all the 4 segments are now, the end of the surface is matching to the feather line. Now let's turn the bottom part off, the bottom surface, and let's do it in the upper part of the last. You can see it's not mentioned there. Just do the same command the same way. Select the line and just do OK it. and you have also bottom and upper surface matching to the satellite right now. At the back part, you're going to see that there's also a gap, so the surface is not closed here, okay? So we are also closing this using the same command. Just pay attention. Right now, you just select the two edges from the surface. Just at this point, you do not cross match edges by closest point. You just keep that empty, and you can see that the surfaces are not now closed at the back. So now that we have the base upper surface and the bottom surface, now we are going to create the new center axis. So you go there on view center. For creating the view center axis, you have to define 2 points on the back part, beginning of the view edge. So usually use 30 and 50, but there's different standards. You can use 25 and 60 and so on. Let's just do 25 and 50 for this example. Okay. And then we go and press run. What it's going to do is it's going to create an axis over the view center line. So you can basically align the last or by the last mid axis or the view axis. So it basically created a point there. You see there? That's the point, is the mid of the view center axis. We are going to mirror the fairlight, so it's also in a way of ensure that there's some symmetry in the bottom, in the fairlight. If you want, you can correct it. Let's just do it 20 and 60 to see if it looks a little bit better. Let's mirror the fairlight to see if the symmetry looks a little bit better. Yeah, looks better. We are not correcting this right now. We'll correct it, but it's not the case. You're going to see later how to correct that. Let's just keep like that. And now let's just press twice over the viewports so we can restore the viewports.